Hi, this example we're gonna look at the series and parallel and to combine all the concepts of basic circuits together. Now you can see this diagram and you have power 80 volts applied, and R1 and R2 is in series and R3 and R4 it's in parallel. So there are a few things we need to find out. This is going to be a very comprehensive problem. We're going to find the current that going through each individual resistor. Okay. Also, we're going to find the voltage going through across each of the resistor. Then the power used for each individual resistor. Okay, and then we can find the total power. Okay, and also we need to find the total current. Total voltage is going to be 80 volts, right? So this is what we are going to look for. So how do we solve this type of problem? First of all, we're going to look at the equivalence of resistance. We know R3, R4, it's in parallel. So it's going to be 1 over R3 is 10 and R4 is 1 over 40. So go ahead and solve that. That's going to give 540. So that answer is going to be 8. So the equivalent of parallel R3 and R4 give us 8 ohms. And then if we are going to look at the total equivalence now, the second step, equivalence for this entire diagram is going to be R1, R2 in series, so 20 plus 12, then plus 8, that's going to give us 40 ohms. So that's entire resistance. Actually, this is what I want you to find out also, why not add there? So you figure out that first question. And how about the current? The entire current, so basically it's total current. We're going to use Ohm's law, V over R. This V is going to be total voltage. That's 80 volts. This total resistance is what you just calculate, 40. So the current is 2 amps. So what that is that's the I here. And this will be the same I. This will be the same I because they are in series. The current going through components in series is the same. So you already calculate this I1 is equal to I2, right? It's equal to I, equal to 2 amps. However, once they started to over here, they're going to split it up to our I3 and I4. I3 and I4 doesn't have to be identical because they will not be. But how do we know for sure, right? We needed to find I3 and I4. So here is the thing, how do we figure it out? If we're using Ohm's law, I3 is going to be the voltage over R3. But do we know the voltage? Do we know V3? We do not, right? We do not know V4, even though we know V3 and V4 are equal. Why they are equal? They're in parallel, right? So they're going through the same node. That's characteristic for parallel circuit. The voltage across those components is the same. So our mission has changed. We need to figure out the voltage. So we're going to put on hold of this I3 and I4. So we need to go back to figure out the voltage across resistor 1 and resistors 2. V1. So we can use Ohm's law for each individual component. So we're going to use for resistor 1 to figure out V1. It's I1 times R1. Our I1 is already equal to 2 amps. Then our resistor R1 is 20 ohms. So that's going to give us 40 voltage. We're going to use the same Ohm's law. Figure out the voltage across resistor 2. The current is also 2. However, the resistor now is only 12 ohms. So that's only have 24 volts of voltage drop. Now, remember, when we are looking at things in series, so if I were trying to simplify this circuit, I will have the first resistor R1. They also have resistors R2. And now I'm going to simplify this parallel. That's going to be our R3 and 4 going back. You already know the voltage drop here, V1, is 40 volts. And V2 is 24 volts. Entire voltage drop is 80 volts given. And now we need to figure out V3 and 4. What's that equal to, right? They are connected in series. If it's in series, we know the voltage, the total voltage, is going to be equal to sum of all those voltage drop together. So 80 volts is distributed to R1. R1 took 40. R2 take 24. Then remaining one goes to the parallel series, V3 and 4. Then we can calculate that. 80 minus 24 minus 40. That will give us 16. Right? So that's going to be 16 volts. And this basically telling us V3 and V4, they both equal to 16 volts because they are in parallel series. So V3 is going to be equal to V4. In parallel, the voltage cross is the same. Now, remember, going back, we need to find our current. I think now we are getting there, right? Because now we can use Ohm's law. We can use I3, it's going to be V3, we just calculated, divided by R3. Okay, so let's go ahead and figure out I3. The voltage drop across resistor 3 and resistor 3. We know it's 16 volts. And R3 we know is 10 ohms. Then that'll give us 1.6 amps. Again, I'm going to emphasize I3 is not equal to I4, right? However, V3 is equal to V4 because they are in parallel. So there are some different ways to solve I4. You can use Ohm's law here. Voltage across resistor 4 divided by resistor. That's 16 volts as well. Our R4 is 40 amps right here. Then that will give us 0.4 amps. That's one way to solve. Or you can consider, remember that branch I is branched up to I3 and I4, right? That mother stream I right here is branched up to I3 and I4. And we know this I, because we calculated, that's 2 amps here. So 2 amps. And you calculated I3 earlier, it's 1.6 amps. And then you can calculate I4, then you get the same answer, 0.4 amps, either one. Well, let's take a quick pause, see what we have gotten. We figured out I1 and I2, 2 amps here. Then we also figure out I3 and I4. We took a little detour, and it's a necessary detour because we need to find our V3 and a V4. That's where we're going. We find, in order to find a V3 and a 4, we find a V1 and V2 first, right? And using Ohm's law, and then we add all those voltage together equal to 80, then we find a V3, 4. Once we find that, we use Ohm's law or the current split. We figure out each individual current. So we basically solve all those here now, right? Total current we also solved. Total current is 2 amps here. And we just need to figure out the power for each individual. So now let's look at it. Power, if we use power V1 I1, that's going to be easy because you already know V1, it is 40 volts. And you also figured out I1 is 2 amps. So that's going to be 80 watt. So do the same thing. You can find a V2, I2. V2 is 24 volts. And our I2, remember, they are the same current, I1, I2, since they are in series, so times 2. That's going to be equal to 48 watts. Then P3, again, for power, you can also use I square R or V square over R, or you can use VI, either one. So our voltage 3 is going to be equal to 16 volts, and our I3 is 1.6, right? So that's going to be 19.6 watt. Is that correct? Let's see. Oh, wrong. This is not right. It's 25.6. Then power 4 is going to be equals, the voltage here is also 16 volts, and I4 is 0.4. That's going to give us 6.4 watts. Okay. Then if you want to find out the total power, we can add them together because those are the 4 things together. So P1 plus P2 plus P3 plus P4. When we add them together, let's see what we have. It's 128. Then this going to give us as 32. Then we'll have 160 watts. Okay, that's one way to figure out the total. Or if you want to figure out the total, instead of adding them together, I'm going to use total voltage and times total current, right? We know the total voltage, there are entire 80 volts there. And total current, we figure out is 2 amps. After that's down after we figure out the equivalence. So it's 80 times 2. Then we got 160 watts. That's equal. And again, that verify all the answers here you have for each individual power is correct. So that's for this problem. And hopefully through this problem, you have a clear understanding how to solve the problem for both series and parallel. That's all. See you next time. Bye.